Hello everybody, I hope I'm audible right now. Just a sec, give me a moment. Alrighty, this seems to be better. Let's simply continue. So coming back to this. Okay, so what are we gonna be doing right now? Just like earlier, we are gonna be going through the previous topics that we've covered so far, and we'll be digging deeper into the things if we face them difficult to understand and all. So at least if it's 8:45, so assuming that the live stream is gonna be 3 hours long, and till 12 or something, we'll just simply keep doing it, and let's see what's gonna happen later. Okay, I hope I'm audible. Am I? Yeah, I am. Without any further delay, let's simply get going. So far, we have discussed about V8 engine, libuv, and event loop, how Node.js work, how Node.js is JavaScript is a single-threaded language. As for Node.js, it is the hybrid, it runs JavaScript on a single thread, but when JavaScript gives some API requests, or it gives some operations like read and write files and all, so it handles that using multiple threads. So JavaScript, ultimately Node.js has four threads, worker threads, to handle the tasks assigned by master thread. So ultimately Node.js runs JavaScript on a single thread. On the other hand, Node.js has four worker threads in libuv that handles the job given by the master thread. So it's like it is the hybrid. It is sometimes single threaded, it is sometimes multi-threaded. When it comes to running the JavaScript code, it is a single thread language. When it comes to handling the tasks assigned by master thread, it handles them in a multi-threaded way. So this is how it just simply goes on. So we've talked about all these things. So ultimately processing at scale, Node.js, single thread, multi-thread. We've even talked about internals of libuv, and especially when it comes to internals of libuv. So libuv has next queue. Ultimately, when it comes to flow of when it comes to queues in libuv. So queues in libuv, of course. So when it comes to this, so there are different queues. The first one is gonna be next tick queue, I think. Next tick queue, and then there is something called micro task queue, and inside micro task queue, what happens that, and they are as per their priority. So this next queue has the highest priority, then micro task queue has the second priority, and all the promises, if there's a promise, ultimately there's a promise callback that just simply goes here. So all the promise callbacks, they are pushed here. So callbacks, and suppose there is what can I say, you are making an API call. Okay, not API call, actually you are promisifying something. So there is a promise, and that promise has a callback. Suppose usually promises are written like this: new promise, and then it has reject and resolve, just like this, and then it has a callback, right? And at the end, console.log, or even without even doing that, we are just simply gonna be resolving this. So resolve, just like this. So it has this particular callback over here. Not only this, there are some promises, like I had better just go with the code block here, /code. So apart from this particular thing, especially when it comes to promise, so promises are written like this as well: promise.resolve, just like this, and it has a callback inside this. So even this callback, so whatever callbacks it has, like this one, so this particular section, so these sections go in the micro task queue. So this is it. And after micro task queue, we have macro task queue, and they are as per their what is that called priority. And when it comes to micro task queue, so first of all, timers queue come. After that, IO input queue comes, and after that, what actually happens, that polling happens. So what is polling? We've even talked about it yesterday. Then checking happens, and lastly the one tick gets closed. So in the timers, all the set timeout related or set interval and all, ultimately these callbacks are pushed. Set timeout and timer related callbacks are pushed. Inside IO, all the reading file related callbacks are pushed. So reading file related callbacks are pushed. The only thing is that once you start reading a file, there could be possibility that the file hasn't been read. So this polling means the operating system will notify Node.js that okay, the file has been read right now. You can check the IO, you can get the callback from the IO input queue, and then just simply process that. So this is how it just simply happens. That simply means if the one tick runs, so all the timer callbacks are gonna be running. After that, there could be possibility that this checking runs before IO runs. Why? Because there could be probability that the file hasn't been read, so there are gonna be no callbacks here. Hence, this checking is gonna run, and this checking queue actually contains a set immediate. So this might be running even before IO callbacks and all. And at the end of the day, this is definitely gonna be closed. So this is what we covered actually yesterday. I mean, we've been just simply sort of going through all these things. And coming back to this particular thing, we've talked about FS module. Even when it comes to libUB, so libUB gives us FS modules, networking related APIs, REST APIs. Ultimately, it gives us FS covers that. It gives us networking related functionalities, and it even gives us the capability of creating child processes. So if you heard of something called cluster, so cluster is responsible for creating child processes. So how does it create? It creates using a libUB. So libUB, not UB, it is UB, is responsible for doing that and all. So these are the things that we covered so far, and let's go through this particular section. So today, module in Node.js. So what is module in Node.js? So it is nothing but a way to structure the files in small chunks, so that you can use them anytime you want, right? So that's nothing but just the definition over here. Module is a mechanism for splitting JS programs into separate manageable chunks that can be imported when needed. So ultimately, this is nothing but functions that we create. So the functions that we create, and then we just simply export those functions, and after exporting, we just simply import those functions. So that is called module. And what are they? They are a way, or that is a mechanism. It is a mechanism to split or code into functions. That simply means into small parts that can be exported and imported as per the need, or wherever they are needed. It's just pretty simple. Anyway, if you are using this Notion, so you can use AI over here. So we can ask what is a module. I never used it, so let's see how it answers it. So a module is a way to split JavaScript and Node.js program, separate manageable file chunks, so you can use code and keep projects organized. Why modules are used? Wow, that's great. It just simply answers it quite well with the problem. Amazing. It uses ChatGPT 5.2. Literally, it gives us. Is there any credit? That's amazing. Is there any credit required to use Notion AI? It depends on which Notion AI feature you are using. Normal Notion AI features, writing, summarizing, Q&A, you usually no separate credits are required. Custom agents. That's great. We can even talk. Hi there, can you hear me? Hello, am I audible? Okay, we need to click this. Yes, I can hear you now. Alrighty, this is not bad, and we have these models over here. It turns out that we can use any one of them. Yeah, any one of them can be used. Fable 5 requires business plan. Okay, that's great. Some of them they do require business plan, but at the end, ChatGPT 5.5 is 5.2, 5.4, 5.5. Hi. We can send messages, and it's gonna be just simply replying. Okay, that's great. Coming back to this, let's simply collapse this, get rid of this. So we've covered this mechanism section, ultimately module section. Then npm is pretty simple. Npm is nothing but a node package manager that is used for installing the packages as per need. So this is a package manager that has a lot of packages written by other people. Now when you need those packages, you just simply install using npm, and that is it. The way we have npm in node.js, the same way we have pip in python, and probably cargo, yeah, in Rust and all, if I'm not wrong. By the way, Telegraph, this is the npm package again. You can create Telegram bots here, Telegraph, but the thing is that Telegram is banned for now, so let's not worry about this. But let's just simply go through the code. Hopefully by 22nd of this month, it's gonna be unbanned again. Coming back to this one, Telegraph, how do we use it there? Should we? It's pretty easy to use. It's pretty easy to create a Telegram bot, sort of the easiest way. So things are not really mentioned over here. So I get a Telegraph npm. Here we are, and ultimately what do you do here? That this is the overall code. First of all, you install it, of course. Once that's been actually installed, then you instantiate. This is nothing but a class Telegram. So you instantiate that with a token. How you are gonna get the token? You get this token from Telegram. So if I'll show you exactly how you can get the token. But ultimately get the token from Telegram, create this particular bot here, and run this code on your server. So create an express server or just a normal server. Even express server is not required. Create a server. Once the server has been created, and after that just simply get the token, instantiate it, and then bot.start. Whenever it will start and it will say welcome, so on your Telegram you will get this welcome message automatically. Then bot.help, whenever just a minute, help ctx, whenever you say, I mean, this is gonna be a help message on your screen only. So probably after 20 seconds we can just simply go through it. So whenever you send any sticker, at that time you will get this reply. Whenever you send hi, at that time you will get this reply, and bot.launch is gonna be just simply launched. So this is pretty simple. You can just simply go through more documentation of it. As for like how it can actually be implemented, that's pretty simple. You can just simply Telegram bot, right? So you can get the token from here. So you have to go to Telegram, get search a bot father, and from there just simply follow the steps, and you will be just simply getting them. This is again one of the other codes. So we are just simply starting it. This is the start help, like starting message. Then this is the another message, like the help message, and after that when we send a sticker we get this. When we say apple, we get apple. When we say laugh, we get laugh, just like this. So ultimately we are sending some what is this called, we are the command, we are sending a message, apple, sort of this is the identifier. On the basis of that thing, we are just simply we have a callback that just simply posts it to the queue, and just that is just simply processed and all, and that is it. We have hi, we have command, quit, we can even quit it. So it has something called here's, it has command, it even has message sticker. So there are many ways to just simply send the messages and all. So this particular thing we've gone through as well. And fetch from GitHub and send to the bot, that's pretty simple. You can actually do that. You can make a request to GitHub, get the code from there, and after that give it to the chat bot, and the bot is gonna be responsible for giving you in result. So ultimately we are not even doing that here, so let's not worry about that. So this is the thing that we've gone through, pretty simple one. So 18 to 12, that's done. In the 13th section we have networking related stuff, so let's just simply go through that. Especially when it comes to networking, so we must have OSI layers, and also when the client sends the request, we have a three-way handshake, that is right, and we have the OSI layer. So ultimately, yeah, it does make sense. Let's go through this. This is gonna be better. Just a sec. Alrighty, it may not be visible well, but okay, never mind. So ultimately what's gonna happen here, that whenever we make a request, so suppose there is a client, there is a server, I better just simply draw it. That would be even more understandable. Coming back to this, so ultimately this is the client. Come on, not this. This is the client, this is the server. Now if both of them want to talk to each other, so first of all I'll make a TCP connection. So a TCP connection is gonna be ready. TCP, what the hell? So ultimately what will happen? A TCP connection will be ready first of all. And how does the TCP connection gets ready? We'll talk about this. But first of all, a TCP connection between them will establish, and once that is established, then my client will send the request. And once the client actually sends the request, the server can actually respond back. So this is actually, it happens. This is nothing but a client. So whenever we double click, the center is this thing. I'm not getting how this particular functionality is implemented, but we'll see. And apart from this particular thing, this is gonna be the server. So this is how it just simply works. Now the question comes, what's the way how the TCP connection gets ready? So ultimately when it comes to a TCP connection, so this is the client section, this is the server section. So you send a handshake request. So a request is sent. Now this is really bad. You actually send a handshake request to this. So this is, you send what? Ultimately you send a request, and what happens that server just simply checks the request, and after that server sends you another request. Server acknowledges that request, that okay, you want to join me, that's fine. Then server sends you the request. Now you need to acknowledge that, that's okay, server also wants to join, server is ready to join. And then you send a server that okay, I'm also ready to join. And then the you just simply, you and the server, and the client and the server, they just simply get connected. Again, this is not the best way, so let's just simply go through the example. Just a second. Alrighty, then got some work, so I'll actually have to go for that and get that particular thing done. But before that, let's just simply talk about this last thing. So ultimately when you are making a TCP connection, it's not quite visible, but okay, never mind. So when it comes to TCP connection, so you just simply send a request, come on, TCP connection. So whenever it comes to TCP connections, you send a sync message, and the server acknowledges that and send you sync message again, and then you acknowledge that back. And this way the TCP connection actually gets built. But the question is, what is this sync and acknowledge? So in that case, we'd better ask this thing to the AI. So today we are gonna be, or instead of asking the AI, how does come on, how